and welcome to Easy Math channel. This week we will look into volumes of solid figures, and we'll look at volume for a cube, which is this, volume for a cube, volume for a rectangular solid, cylinder, and also cone, and then we'll also look at rectangular pyramid. So before we jump into solving volume for each of these solid figures, I wanted to again give a quick refresher like I did in last week, where I discussed about calculating surface of solid figures. So in that video we talked about some of the terms that are important in order to calculate volume or a surface of any given solid figures. So if you have not watched my last week video, which was about surface of calculating surface for solid figures, I would recommend going back to that video and watching it again. And also at this time I would also like remind you to subscribe to my channel. Okay, so before we jump into calculating volumes for solid figure, let's just look at some of the terms. So the first term is face, and face is nothing but a flat surface for any given figure. So for example, if we look at cube, so this is a face, this is a face, this is a face. So in a cube or in a rectangular solid, we have total of 6 faces. So this is first the front face, top face, side face, the one on the back, which is the fifth face, and one at the bottom, which is sixth face. An edge is nothing but lines. So let me change my color and look at this. So edge is nothing but lines that connect two faces. So this line connects face 1 and face 2. This line connects face 1 and face 4. This line connects face 2 and face 3. So edge is nothing but a line that connects two faces. Vertex is nothing but a specific points where more than two faces meet. So let me change the color and look at that. So vertex is nothing but these points, all these points where more than two faces meets. So for example, at this point it's phase 3, phase 5, and phase 6 meets. At this point it's phase 4, phase 6, and then phase 5 meets. So vertex are nothing but all these edges, not edges, sorry, all these points. And base is nothing but the part on which, or the face on which the solid figure rests. So in this case it's the phase 6, which is the face of the and which is also the bottom face of a cube. So again, base is nothing but the bottom part or the face of the bottom of a solid figure. Great. So with that knowledge, let's move on to our next examples, and we will solve examples to calculate volume for each of these given figures. So first let's look at volume of a cube. So in this case we have a cube, and let's say length is 4, the width is 4, and also the height is 4. Length is also called L, width is also called W, and height is also referred as H. So let's say our base, height, and width is all 4 in a given cube, for a given cube. And the way we'll calculate volume of cube is we'll just multiply every single term. So length times width times height. So in this case it's 4 times 4 times 4. and we'll get 64. Now since it's, let's say if all these figures were in meter, so say 4 meter, 4 meter, 4 meter, our answer will be 64 cubic meter or 64 cubic meter. Why cube? Because we are multiplying 3 times, so even meter gets multiplied 3 times, that's why it's cube meter. Cool, so that's how we calculate cube. It's nothing but it's length times width times height. Let's look at another example, which is for a rectangular solid. Now a rectangular solid and a cube are kind of similar. The only difference is for a cube, all the sides are equal. That is, length equals width equals height. Whereas for a rectangular solid, length, width, and height, they all have different measures. So that's the only difference between a rectangular solid and a cube. So for example, let's say we have this rectangular solid with length of 3 feet, width of 2 feet, and let's say height of let's say height of 6 feet. So the formula for volume of rectangular solid is again similar to cube, and you know, because cube and rectangular solid are similar kind of looking figure, the difference is rectangular solid has different measures for length, height, and weight. Height and width, whereas for cube all the sides are equal. So the formula still remains the same for calculating volume of a rectangular solid. So if the height is 3, if the height is 6, width is 2, and length is 3, so for this example, our volume would be 3 times 2 times 6, which is nothing but 36, again, cubic feet. Or 36 cubic feet. Again, why cube? Because we are multiplying 3 times, so feet is being multiplied 3 times. Therefore it's cubic feet. Cool. Let's look at another example, which is for calculating volume for a cylinder. Now let's say this is our cylinder with height of, let's say height of 10 feet and a radius of 3 feet. So the way we'll calculate volume of cylinder is base into height, and since you can see base is this part or this side which is a circle, therefore base is nothing but pi r square. So for this cylinder with a height of 10 and radius of 3 feet, volume would be base, which is pi times 3 squared, r squared, and r is 3, times height, which is 10. So this would be pi times 9 times 10, be 19 pi. And again, since it's cubed, so this would be again cubic feet. And we can leave in terms of pi the answer. Or if you want, pi usually is 3.14, and you can replace pi with 3.14 and you can write your final answer. But it's okay to leave, for a given volume or a surface of solid figure, you can leave the answer in terms of pi, which is perfectly fine. Cool. Let's look at another example, which is volume of a cone. Now this is our cone, and to give you an example, a cone, you can compare a cone to a waffle cone or a traffic cone. Like if you have seen like traffic cones on the street, that's a cone looking figure or a waffle cone. So the way we'll calculate volume for a cone is 1/3, which is 1/3 times base times height. And again, if you look at a cone, the base is again circular. So the base is pi r squared. So let's say if the height of a cone is 6 feet, and let's say the radius or r is 4 feet, our volume for a cone would be 1/3 pi times r square, which is base, times height. So this would be 1/3 times pi times 4 squared is 16 times 6, and this is 2 times, so this would be 32 pi, and again cubic feet, or 32 pi cubic feet. Cool. So that's how we calculate volume of a cone. Now let's look at our last example, which is a rectangular pyramid. And again, if you look at the formula for a pyramid versus formula for volume of cone, it's the same. It's 1/3 base into height. The only difference is base. For a pyramid, base for a rectangular pyramid, the base is more, it's rectangular, and therefore its length times width, versus for a cone, it's circular, and therefore the base is pi r square. So let's say for this rectangular figure, our height is 10 feet, length is 12 feet, so L also means length is 12 feet, and let's say our width or W is also 12 feet. So the way we'll calculate volume for this rectangular pyramid is 1/3 times base, and base is length times width, so and length is 12, width is 12, and height is 10. So we know that we can just divide this, so it's 4, so this would be 48 times 10, this would be 480, and then cube, this is all feet, so this is cubic feet, or 480 cubic feet. So this is how we calculate volume of a rectangular pyramid. So with this, we have seen like examples for each and every rectangular solids, sorry, not rectangular solid, but solid figures that we will usually see more very commonly for in any mathematical examples or any mathematical books. So this is how we do volume for cube, volume for rectangular solid, volume for cylinder, volume for cone, and volume for a rectangular pyramid. I hope this video was useful, and if you like this video, please subscribe to my channel Easy Math, and please leave your comments below. Thank you.